We're going to combine different functions with addition, subtraction, multiplication, and division. So for example, if they give you f of x equals x plus 2 and g of x equals x squared plus 1, and it asks you to find f of 3 plus g of 3. What this means is I'm going to actually plug in 3 for the x in both places since they both had a 3 in them. So f of 3 plus g of 3 would look like 3 plus 2, that's the f of x piece, plus, so this plus is from this guy, and then I'll have 3 squared plus 1. Now I'm just going to use order of operations to evaluate it. So that will be 5 plus 9 plus 1. I could put parentheses around them, it doesn't really matter. Then I'm going to add everything, so it will be 15. The other way you might see it written as f plus g of 3. These two are equivalent things on this left side. Likewise, you might also see f minus g of 3. Since we've already done order of operations and figured out that this is 3 plus 2 minus square root of 3 plus 1. So that would be 5 minus 10. And negative 5 would be what your answer would look like for f minus g of 3. And again, you might also see f of 3 minus g of 3. Same difference. Okay, you can also do multiplication. They might ask you to do f of 3 times g of 3, and it could be written like that, or they might just have fg times 3. So, or of 3, fg of 3. So what that would look like, you'd have 5 times 10. So since we've already done those order of operation things right here. And so whoops, I'm writing it wrong. F times g of 3 would equal 50. Okay, you can also do division. So they could do f of 3 divided by g of 3. That would just look like 5 over 10, and your final answer would just look like 1/2. The other way that this could be written would be f slash g of 3. Okay, I'm using the same equations. They might also ask you to just find it of f, so it might look like f plus g of x. And that all you're going to do is rewrite everything with actual x's, plus x squared plus 1. So this is f, this is g, and your final answer will look like x squared plus x plus 3. So just combine those like terms. And you don't necessarily have to write f plus g of x on every line, but I like to see it on at least the first line and the last line. So if you only have 2 lines, you do have to write it on every line. Okay, f minus g, will make sure you do the g throughout, or the negative sign throughout everything that is in g. So this would look like x plus 2 minus x squared plus 1. So a lot of times what people do is actually leave off these parentheses, and that is not correct. So make sure you actually put those parentheses because we're going to have to distribute this negative sign throughout everything. So this will be x plus 2 minus x squared minus 1. So f minus g of x will look like negative x squared when we write it in standard form with that highest degree first, plus x plus 1. So 2 minus 1. Okay, so that's how you're going to do minus. your multiplication. So you'll actually probably have to FOIL most of these out. So f times g of x. I always write a dot between my numbers, but in the book what you see a lot of times is just fg of x. So I will take x plus 2 times x squared plus 1. So when I actually multiply it out, I'll take x times x squared, which will give me x cubed. X times 1 will give me 1x. I'm not going to write the 1. 2 times x squared is 2x squared. And 2 times 1 is positive 2. Write it in descending order. And I will have x cubed, if I can get a 3 out of there, plus 2x squared plus x plus 2. And that will be f times g of x. And we do pretty much write everything in parentheses. For division, we have to make sure that whatever is on the bottom is not actually 0. So we will have to actually state our domain every time we do one of these. So, okay, usually the division ones are really simple. So you'll just have x plus 2 divided by x squared plus 1. In this case, the bottom doesn't actually factor since it's a plus here. Normally you would simplify it though. Since there's not anything that x can equal, no matter what I plug in there, I will get something that's not 0. So I don't have to worry about stating what my domain can't be for this thing. A lot of the questions just ask what is the domain of each of these things. So what numbers can I plug in for f of x in this case? So the domain of f I can't write my f. My domain of f, I can plug anything in there. So my domain in that case would be all reals. And I'm just going to write my fancy r, or you can also write negative infinity to infinity. Okay, my domain of g, I can plug anything in there as well. So what that's going to look like is all real numbers. Again, negative infinity to infinity. Okay, f plus g will be the same thing. F minus g, same thing. All real numbers. Pretty much all of these, your f, your g, whatever they have in common, in this case since they're the same thing, they're everything in common, will be what f plus g, f minus g, and f times g equals. So these are all real numbers. But then when we come to f over g, the one thing that I have to make sure that I don't do is I can't make the bottom, which is g, equal to 0. So what I'm going to do is I'm going to say, when is g of x equal to 0? Well, since g of x is x squared plus 1, I'm replacing that on the left side, equals 0 minus 1 minus 1. X squared equals negative 1. And actually, this is a really bad example because I'm going to get imaginary numbers. When I actually take the square root of this, I will get I. So plus and minus I. Just I, actually. Okay, so what's going to happen with that is plus and minus I. Sorry. I'm not worried about anything that I get an I with. If I were to actually have gotten a solid number with no I's, oh, and we haven't actually got to anything of these pieces yet, so this, we're going to ignore that, and we'll do I's, I think, in the next chapter. And so what we're actually going to get, so since this never happens, since the bottom never actually equals 0, it will be all real numbers. Usually it will be like x does not equal whatever the bottom will make equal to 0. So, but we don't have to do that right now. Let's just do one more example where the bottom will not be something nice. So x squared minus 4 and g of x equals x plus 2. Okay, I think you probably have done the plus and minus and multiplication ones fine. Let's do a division one. So f over g of x, and that's equal to x squared minus 4 over x plus 2. So what I'm going to do is I'm going to set the bottom for the domain piece of this. I'm going to see when the bottom equals to 0. So I have x plus 2 equals 0, so x cannot equal negative 2. So that's what my domain is all real numbers except x cannot equal negative 2. Okay, we might also see something I don't think they ever actually ask you, but you can do these in any order, the order whatever they ask you. Oh, they do ask you to do this. So for an example is g over f of x. So I'm going to put g on top, so I have x plus 2 over x squared minus 4. What I'm going to do is factor out the bottom. So I have x plus 2 over, this is a difference of squares, x squared and 2 squared is 4. So I will have x minus 2, x plus 2. Okay, we just got done doing a lot of factoring. But since I have an x plus 2 on top, I can treat it like it was in parentheses. And then I can cancel those two out. I will actually have 1 over x minus 2. But I have to find both numbers where the bottom equals 0. So it's really easy to just right here say x cannot equal positive 2 if I were to solve that, but there's actually the other answer. So I have to go up here and write x minus 2 equals 0 and solve, and x plus 2 equals 0 and solve. So x can not only not equal 2, but also negative 2. Okay, so all reals except for those two numbers. So if you have a squared on bottom, try to always get two numbers to get it equal to 0. We also have something called the difference quotient. This will be the last thing we go over. And you will actually use this as a definition for some stuff in calculus. Okay, the definition of this is f of x plus h, and I'll show you how to actually plug that in, minus f of x all divided by h. So I'm going to give you one function and we'll actually have to plug these in. So this will actually be number 47 that I'll do for you. And it is f of x is equal to 3x minus 5. So what I'm going to do is everywhere I see an x in this equation, I'm going to plug in x plus h. So the first thing I do is I'm going to figure out kind of what x plus h is, or f of x plus h. That's still an h. I keep trying to write a b. That will be 3 instead of x. I'm going to write x plus h inside parentheses, minus 5 outside those parentheses. And then I have f of x is still the original thing I have, and then we're going to divide by h. So f of x plus h minus f of x over h. We're going to get 3x plus h minus 5 minus, remember when we subtract things that we actually put it in parentheses, so I'll have 3x minus 5 all divided by h. And these should all come out very nicely to, some of them won't actually come out to numbers, but a lot of them will. Okay, I'm going to distribute this 3 throughout this x plus h and this negative sign to the 3x minus 5. So I will have, I'm going to move down to the next line, I'll have 3x plus 3h minus 5 minus 3x plus 5. That's still all divided by h. Then I'm going to add like terms. So I have 3x and a positive and a negative 3x. Those add to 0 and cancel out. And I have negative 5 plus 5. That adds to 0. So then right there I have 3h divided by h. My h's then cancel out, and I'm just left with 3. Okay, in calculus, this is called the definition of the derivative. they make it seems really hard when you're in calculus, but it's really not that bad. Okay, I might have some graphs that you can look at. Oh, you will have to look at some graphs. This is my f. Let me pick a different color for my g of x. So g of x will look like this guy. So what they're going to ask you to do is figure out what the domain of each of these things is and the domain of f plus g as well. So the domain of f of x okay, so this goes from -4 to 4, 5, 6, 7, 8 to +8. So the domain here would be, since I have closed dots, -4 to +8. The domain of f of x, or g of x, I'm sorry, oops, colon, is from -1 to, that was 8, 9, 10, 11, 12, 13. Okay. The domain of f plus g of x is the intersection of these numbers. So basically from right here to right here. And that's what it's going to be for f times g plus g and minus g of x. So my intersection here is -1 to 8. For f minus g, same thing. -1 to 8. F times g. Make sure, I don't know how you guys write your multiplication signs. If you make it with a dot, make sure you use a closed dot, because we will use like an open circle-y thing. Sometimes I just get lazy when I'm making dots. So -1 to 8 again. And f over g will be the same things, excluding wherever g is equal to 0. Oops, I should be using closed brackets everywhere. Sorry about that. Okay. When does g of x cross the x-axis? When does that equal 0? Since it doesn't, I don't have to exclude any numbers. Okay, let me just draw another. Maybe let's call something h of x. And I will have it go like that. So maybe if I asked you to find what f over, can't write anything, f over h of x is. So f, so the intersection, so it would be from -2, since I actually drew it at a different place, to +8. And then I would write off to the side, x cannot equal this number. That's totally like the wrong notation to actually do it. X cannot equal 2 or 7. I guess the proper way to actually write this would be -2. Then we go to +2. So from here to here, I have a function. That's a closed dot, or an open dot, because I can't have it. That's a union. Then I go from 2 to 7 into that. Can't actually equal 7, so I actually have parentheses. Another union, and then I would go from 7, and then I would actually include 8, so a square bracket. I'm pretty well fine with how I wrote it right here with the f over h, because I'm about as lazy as anybody. But I could also have h of f, h over f of x, and I wouldn't have to worry about excluding anything. So my domain would just simply be -2 to 8, because that's where they intersect at. But since f never actually goes underneath the x-axis, I don't have to exclude anything like I had to in f over h. Okay, I'm going to go back a little bit to this page. Something else that they might give you is just say f of x. What that means is multiply it by itself. Whoops, that would just be an x, probably. So what you're actually going to do is just write x squared minus 4 times x squared minus 4. Just write it as many times as it says to. Okay, so that will be x to the 4th, and you'll actually evaluate it and get it as simple as you can. So minus 4x squared minus 4x squared plus 16. And so ff of x would be x to the 4th minus 8x squared plus 16. Okay, and then back to the end. Your homework. This is going to be on page 177, and you're going to do numbers 3 through 75 by threes.